Alright, let's continue with this example. So now I will be simplifying about these cases here, very easy. So every time when you evaluate a limit of a function, you have to test the value first, right? You have to test the value first. So you test 0 power 4, 2 0 power 3, plus 5 0, alright? So now I'm talking about the techniques here, right? The techniques here. So you're getting 0 over 0, right? You see, you're getting 0 over 0, which is undefined, right? Undefined. So it's not okay. Direct substitute is not okay. You can't find the value. But if you put x equals to 0, this one is undefined, right? Undefined. But when it's near to 0, there is a value. Okay? There is a value. So how? You have to factorize the common factor here. So for this case, you can pause the video and try first before you look at my solution. Right? You will be more brilliant, right? You will be more smarter because you think about it. You think before you know. Alright? So you look at this one. The common factor here, you can factorize the x out. You have x minus 5, right? This one, you don't have constant here, this polynomial. So it means that they have a common factor x, right? You get x cubed minus 2x squared plus 5. This is the one, it's a culprit. So you should eliminate this culprit. So this is the one that causing this thing to be undefined, right? So I cancel out this thing. So now I can evaluate the limits of the function now peacefully, right? So I can direct substitute because it's already defined. Plus 5 over bit 0 minus 5, negative 5, right? So you will have 5 over negative 5, you have negative 1. So it means that as x approaching 0, this value approaching negative 1, right? So now, you also can using calculator. You have to learn this. You have to take your time, please, to look at how I'm using this calculator. For a simple case, there is a complicated case that you want to check your answer, right? So you can using this calculator exactly the same here. You using this one, right? Then you key in the function, key in this function here. So how to key in alphabet x power 4? You key in shift beside this one alpha. You pressing alpha. Then look at this bracket, this one, the close bracket here. So alpha x, right? So power of 4. You are using this one, power. So you have this small box here. So power of 4, right? So you key in 4, alright? So you're pressing the button arrow here. So now you key in as usual, negative 2 alphabet x shift x squared. There's a cube here, so cube plus with 5 alphabet x. You do this when you want to check your answer, right? You want to checking your answer. X squared minus 5 alphabet x. Sorry. So you have exactly the same. If you check carefully here, x power 4 minus 2x cubed plus 5x, x squared minus 5x. So now you're pressing the button CALC, calculator, calculate. So x approaching 0. Of course, you don't put 0. You see, if I put 0, I'm pressing double equal, I'm getting mad error. It means undefined, right? It's undefined. So you have to key in a value, calculate. Okay, pressing AC and call back the function. So calculate. So near to 0 means 0.0000001, right? Right. This number very near to 0. You round off, it's still 0. So then you're pressing equal. You are getting negative 1. Can you see that? Doesn't matter here. The value will be very near to negative 1. Yeah. If you calculate, just now you calculate 0.001. Now maybe you calculate more 0. 0.0000001. You see? More 0. So you're pressing equal. Then you're getting negative 1. Can you see that? The nearer the x to 0, the value x to 0, the nearer the value of this function to -1. That's the meaning of limits. You don't just find the answer. Try to think about why you're finding these limits. So, okay, we will go for 2 more examples. Okay, let's look at these examples. So, I will give you a variety of examples, okay? You can try the example first before you're looking how I solve this question. So, if you look at this one, you can directly substitute. As I tell you, to evaluate every limits, you must determine the cases. So for these cases, when x is negative, let's say, consider when x is -2. So I calculate square root of 3, -2 square, plus with 4, -2, minus 4, over with 2, -2 square, plus 3, -2, minus 2. So I think if this will evaluate 12. 12 minus 8 and minus 4, you have 0. Right? 0. This one, 8. 8 minus 8, you have 0. You see. There is a case 0 over 0. When you have a case 0 over 0, this is the case that undefined. You cannot directly substitute. So if this case happens 0 over 0, we're using the method out of the explanation of all the examples now. We are using the method of elimination, the common factor, by doing factorization. So now we're doing factorization first. When this case we're doing factorization, remember. So then you evaluate, factorize, right? Factorize. There must be a common factor. 3x, x. So you have 2 here, right? You have 2 plus 2. Here will be have minus 2, right? 3x squared. 6 minus 2, 4. -4, yes, correct. So this one also, if you factorize, you have 2x, x. You have plus 2. Then you have minus 1 here, right? You see? 2, right? 2x squared. 4 minus 1. Positive 3. -2, right? -2. So correct. So this is the common factor that you need to eliminate. After eliminate, so you have to get the technique of solving this problem, which is factorization. So then you have 3x minus 2 over with 2x minus 1. Now it's okay for you to substitute the -2 inside. There are no problem here. So it means that 3, -2 minus 2, 3 -2 minus 2 over with 2 times with -2, -1, right? Then you will have square root of -6 minus 2, right? -6 minus 2, you have -8, right? This one you have -5, -4 minus 1, -5. So square root of 8, -8 divided by -5, you have 8 over 5. So means that this is your answer. So 8 over 5, right? So this is the answer for this problem. Alright, for this question also, you can using calculator to check your answer. Okay, and I already key in for you. If you look at this one, you have square root of 3x squared plus 4x minus 4, 2x squared plus 3x minus 2. I have already keyed in. So for you, you can pressing the button calculate. So choose any number. I can choose -1.9999 because it's very near to -2, right? You're pressing equal. Then you have the answer 2 square root of 10 over 5. Okay, if you calculate -2.000001, -2.001 is also considered very near to -2, right? So you're pressing equal. You are still getting 2 square root of 10 over 5, right? But don't be panicked why this answer from calculator is different from yours? No worry. Okay, I show you how if you're doing tutorial or any question, you find out your answer different. So no worry. You know that square root from calculator, the answer is 2 square root of 10 over 5, right? Square root of 10 over 5. I have already tell you, if you're using calculator to evaluate the limit, the answer is always correct. So now, why? How come my answer different? So you can do this way. Square root of 8 over square root of 5, right? Square root of 8 over 5 is square root of 8 square root of 5. So you can rewrite this thing. You can multiply the conjugate, right? If you learn surd, you cannot have rational. This is irrational. So you have to multiply with the conjugate of the denominator, which will give you square root of 5 times with square root of 8 over with square root of 5, you get 5. But it's still different from this, right? You can modify. Square root of 2 is square root of 5 multiply with square root of 2 times square root of 4 over with 5. This is just for extra knowledge, alright? Just for extra knowledge. So square root of 5 times with square root of 2, right? Square root of 2, square root of 4. Further simplify. So you will have square root of 4. Square root of 4 is 2, right? Square root of 4 is 2. Square root of 5 and square root of 2 is a prime number, right? So if you multiply, you're getting square root of 5 times 2, getting 10 over 5, right? So this is actually the same as this one. Okay, I have proven to you the answer from calculator, and your calculator and your answer is exactly the same. So this is the way I always checking my answer when I evaluate the limits of a function. So I give you one more example. Okay, this is the last example for this type of cases. The cases means the cases that I mean is you have to test the value here. So for this case, you test the value. You have e power of 2 times 0 minus with 3 e power of 0. You have to do direct substitution first. But this is in your mind, this is not in your step, right? This is not a step, this is just like you try to think about what happened when you put things 0 here. You are getting 1 here, right? E power of 0 is 1, so minus 3 plus 2 over 1 minus 1. You are getting 0 over 0, which is undefined, right? Undefined. And to solve this type of cases, for this type of limits, we're using factorization, right? We're using factorization. So let's see what is the meaning here. So if you, for this case, for example, if you have limit as x approaching 0, so you can do factorization for this. As you know that e2x can rewrite as ex to the power of 2, right? So power of 2, so minus with 3 power of ex plus 2 over with ex minus 1, right? To simplify the way that you can see, it's actually on top here is a quadratic. It's a quadratic form, right? It's a quadratic form. So means that if you rewrite, you can let the y to be ex, right? You can let the y to be ex. You can solve it inside, and you can solve it here. So means that you know that y squared minus 3y plus 2 over with y minus 1. Means I replace the ex with y. Then you can see, so that you can see that this is actually a quadratic. So you can factorize. You can factorize become y minus 1. So here you have y minus 1, y minus 2, right? So y squared negative 3y plus 2, right? So you can see that. So then you try to look at here how you want to evaluate this one, right? So you know x approaching 0. So this one is like your y squared minus 3y plus 1 plus 2. So you have over with y minus 1, right? Y minus 1. So means here also you have y minus 1. This is your y. Then you have y minus 2, right? Y minus 2. Your y is your ex. So means that this factorized, you will become this one. So this is a common factor, right? Common, exactly the same. So you eliminate. This is a technique we use for the case of 0 over 0. So once you already eliminate the common factor by factorization, so you have one more factor here. And now this factor is okay for you to substitute the value here. So e power of 0 minus 2. And 1 minus 2, you have negative 1. Right? So this will be the answer for these cases here. So for more details or other examples, so you can always come and see me. So that is all the examples for you for the case for 0 over 0.